We're solving problem 20 from the AMC 10B from 2020. Let B be a right rectangular prism box with edge lengths 1, 3, and 4 together with its interior. For real R is greater than or equal to 0, let S of R be the set of points in the three-dimensional space that lie within a distance of R of some point in B. The volume of S of R can be expressed as AR cubed plus BR squared plus CR plus D, where A, B, C, and D are positive real numbers. What is BC over AD? So this is like the volume of SR, and so it's like clear to note that inside all of this, the height is 3, the width is 4, and the length here is 4, and this is 1. So we can already find the area of just like the box in the middle. The volume of the box in the middle is going to be 1 times 4 times 3, which is 12. We already know a value, 12. And this value, 12, corresponds with one of these values, D, because there is no variable R here at play. So this is D is equal to 12. And now you might be wondering, how are we going to consider the ones with R? So let's say CR. What is R? Well, I mean, this radii of the circles is R. This distance for these quarter kind of very tall circle things is R. The width here for these boxes, I should say, is R. So with that being said, let's just calculate what CR is. And so what we want to calculate is these 1, 2, 3, 4, 5, 6, 7. So we want to calculate these 6 boxes. So let's just do volume equals, let's take this one here. This is going to be R times 1 times 3. That's the area of 1, but multiply by 2 because there's another one at the back here. So this volume is going to be 6R. Now for the second volume, this is going to be, let's just consider this one here. This is going to be R times 3 times 4. That's the volume of 1 times 2. Volume here is equal to 24R. And now the last one, V is equal to, well, these are the bottom ones. This is going to be R times 4 times, let's see, 1 times 2. V is equal to 8R. So summing up all these values, we get that this total V for all the boxes is equal to 38R. So with only one variable being said, we get that CR is equal to 38, so C is equal to 38, I guess. So we can further solve for B and A. So we can use the same process, except, well, so what do we notice here? We notice that there is going to be, for these shapes, these tubes, I guess, there's 1/4 on each corner, so 1/4 times 4, that's gonna make 1 tube. And the volume of with these tubes, this is gonna be so the area of the circles, pi r squared, using the variable r, times 4. So that's the volume of 1. But we also have to count the other one, since there's a tube thing with a height of 4. There also has to be these tubes of length of heights 1 and 3. So there's also going to be V is equal to pi r squared times 3, and V is equal to pi r squared times 1. Summing up all these values, we get that this volume is going to be 8 pi r squared. this corresponds to BR squared, so B is going to be 8 pi. Now, we would like to solve for A, which is, in fact, these spheres. There's 1/8 of them for every, 8. There's 1/8 of them at every corner. There's 8 corners here. So, it's just like one sphere with radius r. So V is just 4/3 pi r cubed. This corresponds with A, meaning A is just equal to 4/3 pi. Now, the problem says we want to find BC over AD. Well, what do we know? What is, I should underline all these values. Yeah. Okay, so B is 8 pi times 38 over A times D, which is 4/3 pi times D, which is 12. These two cancel out. And then 12, this becomes 6 times 4 times 38. This 6 times 4/3, this is going to be 4 times 2 times 19 over 8, since 6 times 4/3 is 8. These cancels out. Our final answer is going to be 19 when you solve all these systems of equations.